Good morning, my dear students. Welcome back to maths class. This is the class for the new chapters, Introduction to Trigonometry. It is a very important chapter for you. Okay, it is a new chapter for you also. Up to 9th standard, you don't have this chapter named of trigonometry. Okay, it is already you studied from the chapters normal, which is a mensuration, yes, and shapes, triangles, parallelograms. So these and all you prepared up to the 9th syllabus. No, now coming to the 10th syllabus, it starts for the Introduction to Trigonometry. Introduction to Trigonometry. So this is a very important topic, students. Based on this chapter, we have a 10th syllabus for the two chapters. One is Introduction to Trigonometry and the chapter number 8. The chapter number 8 is the Introduction to Trigonometry and the chapter number 9 is the Applications of Trigonometry. So this is two chapters are very important for you in your 10th syllabus. It is a basic only. I want to give you one small short note for trigonometry. So trigonometry, it is a very interesting topic and it is a very important for the 11th syllabus. You have only one chapter, trigonometric functions, trigonometric function, and based on that trigonometric function we have some of the chapters for the 11th. But in your 12th syllabus, it is very important. Based on this chapter, you have a 6th chapter nearly based on this concept. Based on the trigonometric ratios or trigonometry, you have 6 chapters in your 12th syllabus. So students, be careful and be interested and be awareness to take this chapter in an easiest manner. Yes, student. And when you are going to the higher studies, college studies also, you have this chapter basic, and based on this chapter you have many chapters, mathematical applications. You have on papers for for engineering maths or polytechnic maths or somewhere. Okay, and NEET, IIT, JEE, for everything it is important. Okay, for your physics and chemistry also you are using this trigonometric ratios. Main important thing, physics. Okay, yes, student. Let us move to our topic, trigonometry. It is very easy topic, trigonometry. It is come from that basic, the triangles you know. Yes, students. What do you know about the triangles? It is a 3-sided polygon. And it have some more types based on angle. 3 things are there. Based on angle is acute angled triangle. Second one is, what is that? Obtuse angle triangle. And coming to the third one, right angled triangle. And based on sides or your sides also, you have 3 types. The first one is equilateral triangle, when all the sides are equal to. And next, isosceles triangle, when the 2 sides are equal. Now coming to the scalene triangle, when the 3 sides also unequal. Okay, yes, student. Now the next coming to that right angle triangle, only we are going to take the trigonometric ratios from the right angle triangle. Okay, so first this is a right angle triangle. It is right angled at whatever you have to take. The right angle triangle ABC, right angled at B. Right angled at B. Yes, students. And before that, I want to recall you one thing from your previous year syllabus, Pythagoras Theorem. And this Pythagoras Theorem we have in your 6th chapter, triangle. One important 4 mark question, students. Okay, so Pythagoras Theorem. Yes. So from the Pythagoras Theorem, do you know what is that? You have one right angle triangle. Okay, based on this take. So this is your base and this is your height and this is your longest side. Okay, so the longest side, the square of the longest side, AC square, which is equal to the sum of the square of the other 2 sides. So the longest side we are going to take a hypotenuse. So this word also you are used in your 9th syllabus. Okay, hypotenuse is the longest side for you. Okay, so the hypotenuse, the whole square, the square of the hypotenuse is equal to sum of the square of the other 2 sides, which is, what is that? A hypotenuse. hypotenuse, the whole square, which is equal to what is your base height, okay, height the whole square plus base the whole square. So that only you are prepared in your 9th syllabus, students. Yes. Okay, now coming to the 10th syllabus, we are coming that right angle triangle in different names. Yes, students. So take your book page number 174. Page number 174. So see, for this chapter, from the right angle triangle, we are going to take some ratios. So respect to that acute angles. So already you know from your right angle triangle you have a 3 angles, and sum of the 3 angles of a triangle is what? 180 degree. So from the right angle triangle you have one angle is 90. Okay, and the remaining 2 angles A and C. So these 2 angles also on both also acute angle. Acute angle mean you know what is that acute angle? Less than 90 degree is called acute angle. Yes, okay. So these 2 acute angles. So the trigonometric ratios of the right angle triangle, which is respect to that acute angles, that is called a trigonometric ratio. What is the trigonometric ratio? Again I tell you, listen, some ratios of the right angled triangle, it is respect to the acute angles, or called the trigonometric ratios. Yes, students. Okay, now we are going to take some trigonometric ratios. Totally we have 6 trigonometric ratios. How many trigonometric ratios we have? 6 trigonometric ratios. Okay, now and before that I want to explain for the right angle triangle. So from your right angle triangle, opposite to the right angle is called hypotenuse. What is your hypotenuse? Opposite to the right angle. Yes, student. Suppose if you are going to take the angle C is theta. So theta already you know, students. Theta is the symbol which is measured for the angle. So 90 degree, 80 degree, 70 degree. So these and all we are mentioned by theta. Already you know, students. Yes, okay. So suppose I am taking this one. Angle C is theta, which is opposite to theta. That is called opposite side. What is the name of side? Opposite side. From your previous syllabus we are studying about this is a height. Yes, student. Now coming to the trigonometric ratios, we are giving the name, this is opposite side. So what is opposite side? Opposite side which is opposite to angle theta. Okay, and remaining one side, it is based on adjacent to that right angle, that is called adjacent side. What is the side? Adjacent side. So totally 3 sides you have. One is hypotenuse, and next one is opposite side, and third one is adjacent side. So see, students, hypotenuse is the constant. What is that? Which is opposite to right angle. Yes, students. So opposite to right angle, it is hypotenuse in every time, but opposite side and adjacent side, it may be vary some of the places. Suppose this triangle, this same triangle A, B, C. So this is right angle, that is 90 degree. Suppose I am taking the angle theta in A. If I am taking the theta in A means, see student, opposite to angle A, that is called opposite side. Opposite to angle A, that is theta, which is opposite side. And hypotenuse is whatever, the same for opposite to right angle. And this is adjacent side. The remaining side is adjacent side. So for that we are going to take adjacent side, opposite side, and hypotenuse also. Have you got it, children? Okay. So through this right angle triangle, I am giving you Pythagoras theorem. So the Pythagoras theorem is AC square, which is equal to AB square plus BC square. So what is the name of AC opposite to right angle? Hypotenuse. So hypotenuse the whole square, which is equal to the AB is opposite side the whole opposite side. So opposite side the whole square plus BC is adjacent side the whole square. Yes, students, have you got it? Yes. Now coming to the trigonometric ratios. Okay. So totally how many ratios we have? 6 ratios. 6 ratios. So what are the 6 ratios I am going to give you now? Okay. Have you understood, students? So take your page number 174. So this diagram is given in a different, that is opposite to like this. Okay. Whatever it's saying. Okay. Yes. So from the diagram we are giving what is hypotenuse, what is adjacent side, opposite side, everything is given. Yes, students. Okay. Now coming to the trigonometric ratios. What is that? Trigonometric ratios. So trigonometric ratios, in general we have 6 trigonometric ratios. How many trigonometric ratios? 6 trigonometric ratios. So the first one is sin theta. Sin theta. So the full form of sin is SINE sin. SINE sin. Okay. And before that I give you weight. And before that I give you for all angles of that. The first one is, the first ratio is sine. Second one is cosine, third one is tangent, okay, fourth one is cosecant, then fifth one is secant, then finally cotangent, cot. Okay, so these are the 6 trigonometric ratios. So these are the 6 trigonometric ratio. Okay, so for that theta I am giving you. Okay, so sine, SINE sine. So first I am taking the first 3 letters sine, SINE sine theta. And the second one is cos. The first 3 letters here also cosine. Instead of cosine we are using cos theta. What is the name of the angle? Cos theta. Then third one also tangent. So the first 3 letters we are taking, that is tan theta. Tan theta. Then cosecant. So if you are taking the first 3 letters, already we are denoted for a cosine angle, that is cos theta. So don't take first 3 letters. So instead of first 3 letters I am taking 5 letters, that is cosecant theta. Cosecant theta. But we want to read as cosecant only, cosec theta not pa, cosecant theta. And next secant theta, the first 3 letters I am taking in secant theta. Then finally cotangent, the first 3 letters is enough, cot, not cot, cot theta. Okay, so what are the name of the 6 trigonometric ratios? Listen carefully, students. The first one is sin theta. First one is sin theta. And second one is cos theta. Second one is cos theta. Third one is tan theta. Third one is tan theta. Fourth one is cosecant theta. Fifth one is secant theta. Then finally cot theta. Finally cot theta. Yes, students. Okay. So already I explained you. This is your hypotenuse, and opposite to the angle, that is opposite side, and the remaining side is adjacent side. Adjacent side. Now I am going to give you the trigonometric ratio. So the first one is sin theta is opposite to that angle theta divided by hypotenuse. So that is opposite side divided by hypotenuse. Divided by hypotenuse. So this is your ratio for, what is that? Sin theta. So what is the name of the opposite side? AB. Okay. So for that AB divided by, what is your hypotenuse? AC. Yes, students. Okay. Now coming to the cos theta, which is, what is your adjacent side? Adjacent to the angle. Adjacent to the angle theta. Adjacent to the angle theta and divided by hypotenuse. That is adjacent side divided by hypotenuse. Hypotenuse. Got it, students? Okay. And third one is tan theta. So tan theta is the opposite side divided by adjacent side. Yes. Opposite side divided by adjacent side. It is not a different thing. It is same. See, if you want to divide by sin theta divided by cos theta, you are getting the same tan theta. Okay. And before that, see students, adjacent side what pa? BC divided by AC. Okay. And finally, tan theta is opposite side by adjacent side, that is AB divided by BC. It is nothing but the same sin theta by cos theta. Sin theta by cos theta. That is called a tan theta. Okay. Yes. Now coming to the cosecant theta, it is see. So this is a basic two things, the sin and cos only, students. Okay. After that, tan, division of sin and cos is called tan. Okay. And coming to the cosecant, cosecant is reciprocal of sin. Reciprocal of sin. So what is your sin theta? Opposite side by hypotenuse. Now coming to the cosecant theta is hypotenuse divided by opposite side. Hypotenuse divided by opposite side. What is your hypotenuse? AC, yeah. So AC divided by AB, that is called cosecant theta. And one more thing you should know, cosecant theta is same the reciprocal of sin. So the reciprocal of sin is cosecant theta. Yes, students? Okay. Now coming to the secant theta is reciprocal of cos theta. Reciprocal of cos theta. So what you have a cos theta? Adjacent side by hypotenuse. Now coming to the secant theta is hypotenuse divided by adjacent side. Adjacent side. Okay, student. And finally the cot theta, that is also the same. Already you have tan theta, no? So reciprocal of tan theta, that is cot theta equal to adjacent side divided by opposite side. Opposite side. Yes. So secant theta, what I told you, students, hypotenuse by adjacent side. So hypotenuse you have AC divided by what is that? BC. And already I told you secant theta is the reciprocal of cos theta. So 1 by cos theta. So these and all you should know, pa. Yes. And finally the adjacent side divided by opposite side is the cot theta, no? So adjacent side is BC divided by AB. So that is a reverse of reciprocal of what is tan theta. So cos theta by sin theta, or otherwise 1 by tan theta, or otherwise 1 by tan theta. So these are the 6 trigonometric ratios for you. Okay. Now I am going to recall you, students, so listen carefully. So totally how many ratios are there? Totally 6 ratios. What are the 6 ratios? Sin theta. Okay. So what is your sin theta? Sin theta is equal to, see, side opposite to angle A is given to you in book. Now I am taking theta only. Okay. So whichever, you should know the concept, students. Okay. See, sin theta is equal to opposite side divided by hypotenuse, that is AB divided by AC. Okay. And cos theta equal to adjacent side divided by hypotenuse. So that is BC divided by AC. Okay. Then tan theta, which is equal to opposite side divided by adjacent side. So AB by BC. And one more thing, the division of sin and cos, that is ratio of cos and sin and cos, that is called tan theta. Then cosecant theta, which is the reciprocal of sin theta, so that is hypotenuse by opposite side, AC by AB. Now coming to secant theta, which is reciprocal of cos theta, so hypotenuse divided by adjacent side. Then finally the last ratio, cot theta, which is equal to adjacent side divided by opposite side. So that's all, student. So these are the basic 6 trigonometric ratios. Okay. And one more thing we want to know, that is the reciprocal relations. What is that? Reciprocal relations. So what are the reciprocal and which are they? We want to know that. So reciprocal relations of trigonometric ratios, trig ratios, okay. So the reciprocal relations means, see, already I told you sin theta and cosecant theta, they are reciprocal to each other. So sin theta, which is equal to 1 by cosecant theta, and cosecant theta, which is equal to 1 by sin theta. So sin and cosecant are both also reciprocal to each other. Okay, so this is your first. Now coming to the second, I already told you cos and secant. Yes, students? Okay. Now cos theta is the reciprocal of secant theta, and secant theta is the reciprocal of cos theta. So cos theta equal to 1 by secant theta, and secant theta equal to 1 by cos theta. Then finally tan theta is the reciprocal of cot, that is 1 by cot theta, and cot theta, which is equal to 1 by tan theta. And one more thing we have already, you know, tan theta, which is equal to sin theta by cos theta, and cot theta, which is equal to cos theta by sin theta. Okay, so these and all you have to prepare well, students. Okay, so this is a basic for you in trigonometric ratios. When you are thorough in this, what are the 6 trigonometric ratio? What are the trigonometric ratios? 6 trigonometric ratios. And what are they? Sin, cos, tan, cosecant, secant, cot. And how will come? This and all. And which are they reciprocal to? What are they? So these and all you have to prepare well, students. Okay, if you are thorough, the next topic is very easy to you. I hope you students, you all understand well for that trigonometrics, I mean 6 trigonometric ratios. Yes, students? Okay. Now I want to give you some short note for the remark page number 176. Okay. Yes. So the symbol of sin A or sin theta is used on the abbreviation of sine of the angle A or sine of the angle theta. It is not that product of sine and A, sine into A, that is sine A, not like that. Okay, sine A means or sine theta means that is a sine angle of the angle of theta or A. Have you got it, children? Okay. And you have a page number 176, you have one diagram. Okay, look at this, students. And before that we want to know one thing. You know proportional? What is the proportional? You know, from your the 9th syllabus you have prepared to know from the triangle chapters. So that is okay. So for the triangle, see, so the first I am giving you this triangle. So just I want to recall you. Okay, yes. So A, M, P, and I am extending that base in some way, that is B, and that perpendicular, it's moving like that, and I'm going to join this like, okay, and excess one more point I'm going to extend and to take like this and to take like this. Yes, students. So I'm giving you the name for C and Q. So finally you got it. What are they? PAM is one triangle, right angle at M. Okay, and the triangle ABC is right angled at B. Then finally the biggest triangle QAN is right angled at N. Okay, so from that what I am giving you mean, see, so these are the corresponding sides. See, as per the similar triangle property, you know one thing. So the corresponding sides of the triangles are proportional or proportional. Okay, so for that AM by AB, which is equal to, you have AP by AC, AP by AC, which is equal to, you have NP by BC, MP by BC. Okay, so from that concept, proportional concept, I am giving you one thing. So you have a page number 177. See students, so the values of the trigonometric ratios of an angle do not vary with the length of the sides of the triangle. So angle will not vary students, okay, will not vary from the triangles when the length of the sides is going to change. Angle will not vary, that's all students, if the angle remains the same. So that is your important concept. So already see in the 6th chapter we are not completed, no. So in the 6th chapter we are studying about the similar triangles only, okay. After that we know it is very simple use. Yes student, okay pa. And next let us move to our problems, trigonometric ratios. So the first type of questions we want to find all other trigonometric ratio. So that is your first pattern of problems, okay. Yes students, listen. So the example number 1, and one more thing, very important note I want to give you, page number 178 at top. Since the hypotenuse is the longest side of the triangle, already I told you, no, hypotenuse is the longest side of the right angled triangle. So the value of sin A and or cos A is less than 1. So mark it, this is very important to you. The creative one more question will be asking to you. So the value of sin A and cos A is always less than 1. Okay, yes student. So the first example 1 I am going to teach you now. So I am reading the question, listen students. Given tan A which is equal to 4 by 3. Find the other trigonometric ratios. Okay. Students, in your book point of view they are giving K, 3K, 4K like that. Okay. But I am giving you the basic. You don't confuse from that. Okay. So simple. Tan A is given. Now we want to find the other trigonometric ratios, other 5 trigonometric ratios. Do you know what are the 6 trigonometric ratios? Sin A, cos A, tan A, cosecant A, secant A, then finally cot A. So from the 6 ratios we have only one. What is that? Tan A. So from that tan A we want to find the other trigonometric ratios. Okay. Yes. Okay. A, B, C. So for that the right angle is B. Why sir we want to do like that? Means no need pa. Okay, I will take like that also, no problem. Okay, anything you have to draw the triangle. Okay, so this is a right angle. Okay, and tan A, so that's only we are going to consider by theta. So tan theta is given, and before that you should know what is the trigonometric ratio for tan theta. What is your trigonometric ratio? Tan theta is, which is tan A is equal to opposite side divided by adjacent side. Opposite side divided by adjacent side. Yes student. Okay. Now we have a tan A, so that is tan A equal to opposite side you have 4 and adjacent side you have 3. Okay, so it is a easy method I am giving you to use the Pythagoras Theorem. Okay, don't look at that your book, it is given by you in K format. Okay, you don't want to follow this. You have to follow for this simple way. Okay student, so tan A is given, that is 4 by 3. So tan A means opposite side is 4 and adjacent side is 3. So for that I am going to use Pythagoras Theorem. So from that Pythagoras Theorem we know what is the Pythagoras Theorem. The hypotenuse square which is equal to the sum of the square of the other two sides. So for that AC square which is equal to AB square plus BC square. Okay, AC square equal to AB square plus BC square. So use that concept and to find the remaining one side of a right angled triangle. Okay, now AB you have 3, so 3 the whole square, plus BC you have a value of 4, so 4 square. So 3 square you have 9 and 4 square you have 16. So 9 plus 16 you have a 25, that is the value of AC square. If you want to take a square root of 25 to get the value of AC is 5. Value of AC is 5. So already I told you the hypotenuse is the longest side of a right angle triangle. Now you can accept, student, yes, the remaining two sides is less than the hypotenuse only, no? Yes. So we got it, the three sides. Now we are taking the other trigonometric ratios. Yes. Other trigonometric ratios means what are they? First sine A, which is equal to opposite side. You want to write that opposite side by hypotenuse, or otherwise use the letters A, B, B, C, A, C like that. That is your wish, students. Okay, whichever your wish. So sine A means, but initially you have to use that opposite side, hypotenuse, adjacent side like that. Mean the formula, I mean in this concept, it is inside of your brain, it will go. Yes, student. Yeah. So sine A is equal to opposite side by hypotenuse. So write the short form, it's not a problem. Opposite side, OPP side. Opposite side is what? 4. So 4 by 5. And next, cos A is equal to adjacent side divided by hypotenuse, which is equal to 3 by 5. 3 by 5. Then third ratio is tan A, which is equal to opposite side divided by adjacent side. So opposite side is 4 and adjacent side is 3. So already it is given. Okay. If you want to write this, right, always leave it, your wish. Okay. Already I have, so why I want to write means leave that. It's not a problem. Yes, students. Okay. Now after that, cosecant A we want to find. So cosecant A, which is equal to, what is that cosecant A? Hypotenuse divided by opposite side. So hypotenuse you have a value of 5 divided by opposite side is 4. Already I told you sin theta is the reciprocal of, what is that? Cosecant. I mean cosecant theta is the reciprocal of sin A, and both also it's a reciprocal to each other. So cosecant A is equal to 1 by sin A. Already I told you, no. See, sin A is 4 by 5 and cosecant A is 5 by 4. That's all, students. Yes? Okay. And secant A, which is equal to hypotenuse by adjacent side, which is that, what is that? 5 by 3. So this is a reciprocal of that. Okay, reciprocal of cos is secant. Then finally cot A. Cot A is a reciprocal of tan A, that is adjacent side divided by opposite side, which is equal to, you have adjacent side 3 and opposite side 4. So this is a cot A is the reciprocal of tan A. So that's why we are find that other 6 trigonometric ratios. Have you got it, children? Okay. So the first two ratios are important, and then next you have to take that based on the first two things. Sin cos. If you know sin cos means the remaining you should know automatically. How? Sin by cos is tan. 1 by sin is cosecant. 1 by cos is secant, and 1 by tan is cot. Yes, students? Okay. Or cos by sin is cot. Okay, have you got it, children? And the next question. Now let us move to our exercise problem, students. Okay. So the exercise 8.1. Exercise 8.1. Okay. So the first question, listen all of you. In a triangle ABC, right angled at B. Right angled at B. Okay. Question number 1. So right angled at B means we have to draw like this. A, B, C. So it must be the right angle in B. Okay. So right angle at B, and given some values. What are they? Given AB, which is equal to 24 centimeter, then BC is equal to 7 centimeter. BC equal to 7 centimeter. Now I am going to represent through the diagram. Is AB is 24 centimeter and BC is 7 centimeter. Yes, student. So what are they asking the question? Determine the value of sin A cos A and sin C cos C. Sin C cos C. So the first step, we want to do the take the Pythagoras theorem and to find the remaining one side of a right angled triangle. Okay, students. So you have a missing value of the hypotenuse, no? So for that, using Pythagoras theorem. Using Pythagoras theorem. So using the Pythagoras theorem, AC square which is equal to AB square plus BC square. AB square plus BC square. Already you have a AB is 24 square plus BC is 7, so 7 square. So 24 square, 24s are very simple already, you know, 576 plus 7 7, so what is that? 49. So add this to get what is that? 625. 625. So AC square is equal to 625 and we want to take the value of AC. AC means take the square root of this to get, what is the square root of 625? 25. 25 are 625. Yes, students? Okay. So finally I find that value of the hypotenuse also. Okay. Now what they are asking? Find the sin A and cos A. Sin A and cos A. Sin A means I am taking to opposite angle to A, that is BC, divided by, you have a same hypotenuse, that is what is that? AC. So BC by AC means 7 by 25. Got it? Okay. And next cos A means adjacent to the angle A. Okay, that is what is that? AB, okay. AB divided by AC which is equal to 24 divided by 25. Got it, children? Okay. So this is your first question, and coming to the second question is based on the angle C. Angle C. So already I explained to you, we have to change the angles only. Acute angles A and C. We have two acute angles named on A and C. We have to change anything by taking the value of theta, but right angle is a constant, it will not change. Yes, students? Okay. Now the second division is what? Sin C. So sin C means we want to consider this is a theta. So opposite to angle C, that is called the opposite side in that here. So that is AB divided by AC. So AB 24 divided by 25. Then finally cos C. Cos C. So cos C means that is what is adjacent to the angle C. Adjacent to the angle C is BC. So BC divided by AC. So what is your 7 by 25. So like that you have to complete. Okay, student? Yes. Have you got it? I hope you all enjoyed this chapter. Okay, enjoy well, because it is a very easier and it is a very necessary chapter for you in your higher studies. Yes, students? Okay. Now the question number 2, the same pattern of this question. We have to change the angle by P and R. You have a figure also in your book. Okay. So figure 8.13. Okay, so in that figure we want to find the tan P minus cot R. So first use the Pythagoras theorem and to find the remaining side of a triangle PQR. What is the remaining side? QR. So first you need to find the QR. Yes, student. And after you have to take the angle P and to find tan P. Then R and to find cot R. Then subtract on both to get the answer. Okay, students? Yes. And the next question we want to move in that question number 5. So students, the question number 5 also you have a same pattern of that first example. Example question number 5. Example number 1 you have no. So in example 1 they are giving they gave a tan A and remaining trigonometric ratios we are find. Now the question number 5, it is given to you in secant theta. Secant theta. So secant theta means what, student? Hypotenuse by adjacent side. So that is given. So we want to find the opposite side using the Pythagoras theorem in that using triangle. And then find the other trigonometric ratio, that is sin theta, cos theta, tan theta, cosecant theta, then cot theta. So these 2 questions also in your homework. How many questions you have homework? 2 questions. Okay. And next we want to move So students, next question is question number 3. Question number 3. Okay. It is given to you in sin A. Given sin A which is equal to 3 by 4. So this is also the same pattern for that question number example 1. Okay, the same number only students. Okay, yes. Now listen pa. So first you have to take a right angle triangle and mention A, B, C. Okay, by change the sin A is this one you have to consider by theta students. So sin A equal to opposite side divided by what is that? Sin A which is equal to opposite side divided by hypotenuse. So 3 by 4. Okay, so now what are the question asking to you? 3 by 4 sin A is given. We need to find cos A and tan A. Cos A and tan A. So for that 3 okay, we need to find this is opposite side and this is adjacent side. Okay, so first we should find the adjacent side by using Pythagoras Theorem. Okay, so using Pythagoras Theorem, AC square which is equal to AB square plus BC square. Okay, now AC you have 4 so 4 square is equal to AB square plus BC square is 3 square. AB square we don't know, adjacent side. So 4 4s are 16 which is equal to AB square plus 9, and plus 9 we want to move that left side to get 16 minus 9 which is equal to AB square. AB square. And 16 minus 9 what student? 7 okay. So 7 which is equal to AB square, but I need the value of AB only. So to get root 7. To get root 7. Okay. And next we are find that 3 values also. So next we want to find cos A and tan A. Yes students. Okay. Now cos A which is equal to what is your adjacent side now? AB. So AB divided by AC. So AB you find the value. Now what is that? Root 7 apa? Okay. Now root 7 divided by 4. So this is a value of cos A. Okay, and then we want to find tan A. So tan A which is equal to opposite side divided by adjacent side. Opposite side is BC divided by adjacent side is AB. So BC is 3 divided by AB is 4. So 3 by 4. Okay, opposite side is 3 and adjacent side AB is root 7. So that is tan A. Or otherwise you have one more also. What is tan A means? What is that? Sin A divided by cos A. Anyone you have to write students is not a problem. Okay. So sin A you have a value of 3 by 4. And cos A you have a value of root 7 by 4. On both denominator also cancel. So 3 by root 7. So from these two pattern, select any one, that is your wish. Then the last question we are going to see for this class, question number 4. Question number 4. So given 15 cot A is equal to 8. Given 15 cot A which is equal to 8. So what they are asking to find? To find sin A and secant A. Sin A and secant A. Okay student? Okay. Listen all of you. So this is a different question from the previous. Why means from the previous question they are given sin A, cos A, tan A and to find the remaining sides. I mean remaining trigonometric ratios. But this question is different. We don't have a ratio first, any one of the ratio. So first we make it to find the any one of the trigonometric ratio. So from that only we have to find the remaining side and then final answer. Okay. Now see, 15 cot A equal to 8. 15 cot A equal to 8. So I need only cot A means 8. The multiply 15 coming this side, it will come divided. by 15 divided by 15. So finally you got it one answer, that is cot A. So cot A equal to 8 by 15. Okay. So for that I am going to draw one right angle triangle to represent the sides. Okay. Okay, wait. If you have any confusion in this, you have to change that triangle means other side. So like that also. A, B, C. So this is a right angle. So cot A, which is equal to, what is that ratio? Cot theta, what students? Adjacent side by opposite side. Adjacent side here is this one, 8 divided by opposite side is 15. So now using the Pythagoras Theorem to find the remaining side. So AC square, which is equal to AB square plus BC square. Okay, now you have 15 square, AB is 15, 8, okay, AB 8 square plus BC 15 square, 8 square, 8 8s are 64 plus 15 square is 225, 225. So add these two, get what? 225 plus 64 is 289, 289. Okay student, so AC square equal to 289. Now the value of AC equal to, what is the square root of 289? Do you know student? Is what? 17. So the value of AC is 17. Okay. So finally you find all the sides of a triangle. All the sides of the triangle. Now what they are asking? Sin A and secant A only, no? Yes. So sin A, which is equal to, you have what is the opposite side BC divided by hypotenuse AC. Now only you find the value of the hypotenuse is 17. Okay. Now BC by AC means 15 by 17 is the value of sin A. And next what we are going to find? Secant A. So secant A is equal to what? Hypotenuse divided by adjacent side. So hypotenuse you have the same AC and divided by adjacent side. Why you are taking adjacent side mean secant theta is the reciprocal of cos theta. Okay. So adjacent side is what student? AB. So 17 by 8. So secant A, which is equal to 17 by 8. Have you got it student? Okay. Yes student. So today class is going to complete now. So students, exercise 18.1 we are completed up to the 5 questions. First 5 questions. Okay. So from the 5 questions I teach you now. What are they? Already I take first question, then fourth question. So the remaining question, third question also. First, third, fourth. The 3 questions now I explained to you. So the remaining only 2 questions you have a homework. Yes students. So complete these 2 questions. We will meet in the next class. Yes students. So students, be prepared in this trigonometric ratios. Take your own sums and to practice, then only it will come in easy manner. Yes students. Okay students, we will meet the next class. Thank you.